Hello everybody, in this lesson I will discuss grade 12 probability, more specifically 6 past exam questions. This is lesson 4 of 5. Question 1. There are 7 different shirts and 4 different pairs of trousers in a cupboard. The clothes have to be hung on the rail. Question 1. In how many different ways can the clothes be arranged on the rail? Now, do you agree? There's 7 shirts, 4 trousers. Therefore, we say 7 plus 4 is 11 factorial. And the answer you find there is 39,916,800. Question 2. In how many different ways can the clothes be arranged if all the shirts are to be hung next to each other and the pairs of trousers are to be hung next to each other on the rail? Now this means, in fact, there's a group where you will find the 7 shirts, and then there's a group where you will find your 4 trousers. But within the group of shirts, you still get 7 factorial times, and within the 4 trousers you still get 4 factorial times, and then the 2 factorial, that is now for the 2 groups. For shirts and trousers can be arranged in 2 factorial ways. And then your answer, 241,920. Question 3. What is the probability that a pair of trousers will hang at the beginning of the rail and a shirt will hang at the end of the rail? Now, do you agree this implies 1 out of 7 shirts and 1 out of 4 trousers? And then you are left with 9 items. Therefore, the probability will be there's the 7 shirts times the 4 trousers, and then the 9 factorial is, because you are left with 9 items in different ways, everything divided by the total, 11 factorial. Therefore, the answer is 0.25. Question 2. The digits 0, 1, 2, 3, 4, 5, and 6 are used to make 3-digit codes. Question 1. How many unique codes are possible if digits can be repeated? Now, do you agree a 3-digit code? That means there's 3 spaces. So in the first one, there's 7 possibilities, then 7 possibilities for the second space, and for the third space, also 7 possibilities. Therefore, the answer is 7 times 7 times 7, which is 343. Question 2. How many unique codes are possible if the digits cannot be repeated? Therefore, for the first digit, there's 7 possibilities. But now for the second digit, there's only 6 possibilities. And for the third one, there's only 5 possibilities. And the answer, 7 times 6 times 5 is 210. Question 3. In the case where digits may be repeated, how many codes are numbers that are greater than 300 and exactly divisible by 5? Now this means the numbers have to be greater than 300, and that implies that the number has to start with a 3, 4, 5, and 6. That means the first number, there's 4 possibilities. Then, for your number to be divisible by 5, it has to end with a 0 or a 5. So at the end, there you find 2 possibilities. And then the middle number, 7 possibilities. Therefore, the answer 4 times 7 times 2 is 56. Question 3. 3 items from 4 different departments of a major chain store will be featured in a one-page newspaper advertisement. The page layout for the ad is shown in the diagram below, where one item will be placed in each block. Question 1. In how many different ways can all these items be arranged in the ad? Now, do you agree? We need to know the total. From A to L means there's 12 factorial ways. And 12 factorial with your calculator is 479,100,1600. Question 2. In how many different ways can these items be arranged if specific items are to be placed in blocks A, F, and J? Now that means, in fact, that block A, F, and J are fixed. So what's left? We're left with 12 minus 3 is 9 factorial. 362,880. Now question 3 continues here. Number 3. In how many different ways can these items be arranged in the ad if items from the same department are grouped together in the same row? Now this means the items of each department can be arranged in 3 factorial ways. Now, if you look at the sketch, you can see there's A, B, and C. That means 3 factorial. D, E, and F, 3 factorial. The departments in 4 factorial ways. So this means 1, 2, 3, 4 departments. Therefore, our answer is 4 factorial, that's for the departments, times 3 factorial times 3 factorial times 3 factorial times 3 factorial. And the answer, 31,104 ways. Question 4. Every client of CashSave Bank has a personal identity number, a PIN number, which is made up of 5 digits chosen from the digits 0 to 9. And there you will see the 5-digit PIN. Question 1. How many personal ID numbers or PIN numbers can be made if digits can be repeated? Now, do you agree? From 0 to 9 is in fact 10 digits. Therefore, for the first space, 10 times 10 times 10 times 10 times 10, which is 100,000. Question 2. How many PIN numbers can be made if digits cannot be repeated? So remember, there's 5 digits that makes up your PIN. Therefore, in the first one, there will be 10 possibilities. The next one, 9, 8, 7, 6. And our answer, 30,240. Before we continue, have you subscribed yet? And you can also visit my website, onlinemaths.co.za. Also feel free to leave a comment or like my video. Let's continue with the examples. This question is still part of question 4. Number 3. Suppose that a pin can be made up by selecting digits at random and that the digits can be repeated. What is the probability that such a pin will contain at least one 9? Now, the probability that there's no 9 is 9 to the power of 5 divided by 10 to the power of 5 equals 0,59. Then the probability at least one 9 will be 1 minus 0,59 and the answer 0,41. Question 5. Consider the word product. Question 1. How many different arrangements are possible if all the letters are used? Now, do you agree? Inside the word product, we find 7 letters. Therefore, the answer 7 factorial 5040. Question 2. How many different arrangements can be made if the first letter is T and the fifth letter is C? So do you agree? Now the letter T and the letter C, they are fixed and we are left with 5 factorial, which is 120. Question 3. How many different arrangements can be made if the letters R, O and D must follow each other in any order? Now the answer is 3 factorial, and the 3 factorial comes from the letters R, O and D. Then it's times 5 factorial. Now where does that come from? Because if you look at R, O and D, that means if you take out R, O and D, there's 1, 2, 3, 4 letters left. But why is there a 5 factorial? Because the group R, O, D also forms part of the arrangement. So the answer here is 3 factorial times 5 factorial, which is 720. Question 6. In Gauteng, number plates are designed with 3 alphabetical letters, excluding the 5 vowels, next to one another, and then any 3 digits from 0 to 9 next to each other. The GP is constant in all Gauteng number plates. For example, TTT012GP. Letters and digits may be repeated in a number plate. Number 1. How many unique number plates are available? Now, do you agree? The letters, there's 26 minus the 5 vowels is 21 possibilities. And then for the digits, from 0 to 9 is 10 digits. Therefore, in the form where you find 3 alphabetical letters, that means there's 21, 21, 21 possibilities. And then for the digits, there has to be 3. So it's 10 times 10 times 10. And when you work that out, you find 9,261,000 unique number plates. Question 2. What is the probability that a car's number plate will start with a Y? So probability means it's the probability that it will start with a Y is 1 out of the 21 equals 0,0476. Question 6 continues. Number 3. How many unique number plates will be available if the letters and numbers are not repeated. This means, do you agree? The first letters, the first 3 digits letters there will be 21 times, and now they cannot repeat, so it's times 20 times 19, and then for the digits the first space will be 10, cannot be repeated, 9 times 8, and your answer 5,745,600. In the next lesson, I will discuss 5 more questions from previous exam papers. Click on the video in the left-hand corner to take you to the next lesson.